We're going to pick up in Chapter 3, Section 1. We're going to really shift gears now to getting into algebra. And the first section here is simplifying expressions and combining like terms. So we start out here with some definitions. First of all, a variable is a letter that represents an unknown number. We've seen probably in the past the use of X or Y or T or something like that. Those are examples of variables. So anytime we see a letter that represents an unknown number, we will call it a variable. All right. A blank is the number or product of a number and one or more variables raised to a power. This is called a term. And an example of terms would be something like 3x. That's an example of a term. We could have maybe like negative 5x squared. That's a term. We could have just the number 9 by itself. That would be a term. Now all of these have something in common. They're either going to have a number and a letter, or a number and a variable, with multiplication between them. So even though there's not a dot there, it's understood that's 3 times x. Here we have a number and then we have a variable squared. That's still a term. We have multiplication between them. Then here's just a number by itself. That's also a term. Don't be confused if you see something like 3 plus x or 3 plus x squared. This is not a term because there's addition in between. Okay, a blank is the numerical factor of a term. This is called the coefficient. So examples here, if we go back up to the example that I gave here of terms, you can see here that 3 is the number that's inside the term, and that's called the coefficient. Here negative 5 would be the coefficient, and here 9 would be the coefficient. So coefficient is just a number that appears in the term. Here's another example. If you had just, let's say, x cubed, that would be a term. And the coefficient, even though it's not written, would be understood to be 1, because that would be the number in front. So the coefficient of that would be 1. Okay, so for this, we want to look at these and determine the coefficients. So looking at this term, 2 times x, coefficient is 2. Here, there's a 1 in front of that y, so 1. Here, negative 2/3 is the number in front of a times b. Here the number 6, and here by itself negative 5. Now, whenever you have a term that has no variables, we refer to that as a constant term, or simply a constant. So an example of a constant term or constant would be that negative 5 I wrote there. Or back up here when I wrote 9 by itself, those are referred to as constants. So they're just a number without any variables appearing next to them. Okay, so in this group work it says which of the terms in the table above are variable terms. So let me just label these. This would be a variable term because it has an x in it. This is a variable term because it has a y in it. This is a variable term because it has a and b in it. Those are both variables. This one has x squared and y cubed. That's a variable term. And then this one is a constant term because there's no variable. So that's how we could answer the group work for both of these questions. All right, now what we want to do is, now that we know what terms are, we want to talk about simplifying algebraic expressions. And to simplify algebraic expressions, we use one or more properties of algebra to write an expression in an equivalent, less complicated form. And we're going to use a couple of properties to do this. The first one is what's called the commutative property of multiplication. And all it says is that when you have multiplication between things, like a times b, then it's okay to switch the order and make it b times a. And you get the same answer. So in other words, if I had 3 times 4, well, that's the same as 4 times 3. And we can do that anytime we have multiplication between two things. So looking at the following example, if I have 9 in parentheses and then 6x in parentheses, we want to look at this as being like two terms. That's a term right there. That's a constant term, times 6x, which is a variable term. And if I want to multiply them, what I can do is just multiply the 9 times the 6. That would give me 54, and then I just write the x next to them, to the 54. And that's it. On this one, you'll see this property of switching the order here at play. What I can do here to multiply these is I can rearrange this and make it 7 times -3. I'm going to put that in parentheses. And then times p, and then times q. So I'm just rearranging. That's what the commutative property is saying. We can rearrange multiplication however we want. So then I can do this 7 times -3 first, and that gives me -21, and then just p times q, and that is my new variable expression. So I've combined these two together to create something a little bit nicer. That's what we did here also. Okay, so in the group work, I'm just going to work through this group work. Here, we can just multiply the -5 times -4. That'll give us 20b. And then over here, this will just give us 77r squared, just multiplying the 7 times the 11. Okay, now we're going to have a new definition. The definition is for this right here, like terms. So what does it mean for terms to be like? Well, in order for them to be called like terms, they have to have exactly the same variable or variables raised to exactly the same powers. So when you look at this first one, this is 5x, this is -3x. These are like terms, and the reason is they both contain x, and that x is really raised to the first power even though we don't write it. So as long as you have the same variables raised to the same exact power, then we have like terms. These two are like terms. We're kind of ignoring the numbers, the coefficients. We're just looking at the variables. They both have x squared. So that's going to be, those are going to be like terms. Okay, here and here, we ignore the numbers, okay, the coefficients, and we just look at the variables. They both have x, they both have y cubed. Therefore, they are called like terms. And then these, of course, they're both just numbers, right? Just constants. So they both don't have x. And these would also be referred to as like terms because they actually have the same variable raised to the same power because they both don't have variables. You could look at it as they both contain the variable x to the 0, which is 1. So you can imagine this is like 6x to the 0 minus, or time, sorry, so we're not doing any multiplication here. Then that one's like -10 times x to the 0. So you could technically say they have the same variable raised to the same power. So let's see, are these like terms? These first two here. Well, they both have b, right? So yes. Are these like terms? Well, this one has x squared, and this one has x, and those are, even though it's the same variable, they're not raised to the same power. So we would say here, no, these are not like terms. This one was, and that one wasn't. So let's say we have two like terms. We can now learn how to combine them together. So to combine like terms, we simply add their coefficients together. All right? So we have to go back and use the rules that we learned when we were learning addition and subtraction. So looking at these two, 4x plus 5x, these are both like terms, right? They both have x to the first power. All right, so they're like terms. Now, I need to add them together. So this says if we're going to add them, simply add their coefficients. So I just take 4 and 5 and I add those together, and that gives me 9. So I'm just going to have 9 x's. Just think of this as like saying you have 4 apples plus 5 apples, and that will give you 9 apples. All right, so the x is like, because these match up, those are both apples, so we just add them together, we have 9 of them. Now in this next expression, we have to be a little careful here because there's a lot of things added together. So what I'm going to do is I'm going to combine like terms by rearranging things first. So let me do this first, and I'll talk about it after I write it down. Okay, so what I did is I recognized that 7x squared and -5x squared are like terms. So I put them next to one another. And then I realized that negative 15x and minus x are both like terms. They both have x to the first power, so I put those next to one another. And then we have a constant term, plus 1 and minus 6, and I put those together out here. And now what I'm going to do is combine them. So for the first one, since these both have x squared, these will come together. I take 7 and I subtract 5, that's 2, so I have 2x squareds. Here I have a negative 15 and I need to take away, this is really like a 1 right here in front, so I'm doing negative 15, take away 1. Now we did this before, this should be negative 16, and then we still have to bring the variable with it, x. And then I have to do this last one, I'm doing 1 take away 6, that's negative 5. And this is the simplified variable expression. Okay, so now the group work, I'll give you a second if you want to pause it and work those out yourself, but I'm going to go ahead and work them now. So here these like terms. We have a squared, we've got b. Okay, so they're like terms, so I can just look at the numbers, negative 8 and negative 3 or minus 3, so I need to do negative 8, take away 3. That gives me negative 11. So this just becomes negative 11 a squared b. Okay, on the next one, let me group things together here. I have a 4x, oh wait, I see an x cubed in there. Minus 7x cubed and plus 10x cubed. Let me write that down first. Minus 7x cubed plus 10x cubed, okay. Then I have, let's see, a 4x squared, and then I have 11x squared, so I'll put those now. So plus 4x squared plus 11x squared. That takes care of, oops. That takes care of the green ones. And let me see, for as far as x's, I've got minus 9x, I've got plus 9x. So minus 9x plus 9x. And I do have constants also. I have plus 2 and minus 3. So plus 2 and minus 3. Okay, so I've rearranged everything. Now I'm ready to combine my like terms together. So on my first one here, I've got to look at the coefficients. So I've got to take negative 7 plus 10, that's 3 x cubed. And then here I need to take the coefficients, which are 4 plus 11. That's going to give me 15x squared. And then on this one here, I've got negative 9 plus 9, and that's 0. So that actually just gives me nothing. I have no x's there. And then the last one, this is 2 take away 3, it's negative 1. So I could say that my simplified expression is 3x cubed plus 15x squared. I don't need to write 0, so I'll just write minus 1. So there is our simplified expression. Okay, now we're going to continue simplifying, but now use another property of an algebra called the distributive property. So this says that if you ever see something in front of a parentheses and you've got an addition between them, you can multiply through a times b, that's this, and then you do plus, okay, so you keep the plus sign, and then you do a times c, so that's this last one. And the only difference on the bottom one is that if there's a minus there, that becomes minus. So this is called the distributive property, and let's go ahead and use this. So for the first example here, we're going to see that we have something 5, right? 5 times, and then in parentheses we have two things that are added together. So we distribute 5 times p, that's just 5p. And then we say plus, because that's a plus there. 5 times 2, that's 10, and that's it. Okay, we've essentially removed the parentheses. Okay, this one here, same thing. We're going to go 8 times negative 8 times 2x. So you multiply the 8 times the negative 8 times the 2, that gives you negative 16 x's. And then negative 8, and then notice here, let me do this. I'm going to move the minus here. Okay, that was that minus right there. But notice I'm doing negative 8 times 4. Okay, so you're just looking at that 4 and that negative 8. We already moved the minus sign down. So that's why I did negative 8 and 4 here. That gives you negative 32, but we have to subtract it, so something like that. And so this gives me negative 16x plus 32. And that should be it. Now, that's one way to approach it. Now, another way you could approach it that's just as well is to look at this as being this times this gives you the negative 16x. You could, if you wanted to, say that you're going to do this times this, and it's a negative times a negative, and that gives you positive 32. Just be careful with that. Whichever way makes more sense to you is the way you want to do it. But there's the result. Okay, here's a group work. Okay, give you a chance to pause it, and I'm going to work it out now. So here you should get 7n minus 77. Here you should get negative 36w plus 60. And here you should get, careful here, this is like a negative 1 right here. So you're multiplying a negative 1 through, you get negative 5x minus 12y, and then plus 4z. You have to be real careful, because when you do negative times positive, you get negative. But then on this last one here, when you do this negative 1 times a negative 4z, negative and negative become positive, and that's why you get this plus here. So really, by putting a negative 1 on the outside of a parentheses, it changes all the signs. Everything that was positive becomes negative, and everything that was negative now becomes positive. All right. Okay, now we're going to do a combination of the two things that we've done here. We're going to use distributive property, and then after we do that, we're going to combine like terms. So when we look at this, it's real important that you see this is 2x minus 9 times 2x minus 3. Now, remember the order of operations? All right. So when we do this, we always want to do what's in parentheses first. So we look in here, 2x minus 3. Can we do anything to that? Well, those are not like terms, so we cannot combine them at all. So there's nothing for us to do in terms of the parentheses. How about exponents? Well, I don't see anything raised to any power, so I'm going to just ignore that. Now I need to do multiplication. So that means I need to do this multiplication of the 9 through here like this. Now I'm actually going to treat it like it's a negative 9. Okay, and pass that negative 9 through distributive property. So my next line should read 2x, which is just coming along for the ride. And when I do this negative 9, and I multiply that negative 9 times the 2x, that should give me a negative 18x. And then I do the negative 9 again, but now times the negative 3. So I distributed that through, and negative times negative would be positive, so that should give me 27. And now I notice that these two are like terms. They both have x. So I can do on the side here, what's 2 take away 18? I'm looking at their coefficients only. And that gives me negative 16x, and then I still have plus 27, and I can't do anything else to that because those are not like terms. And so therefore I am done. Okay, this last one is a group work. I'm going to let you work that out. Pause it if you want. Let me go ahead and work it out though. So we have, what I'm going to do here is I'm going to distribute here. This is a negative 1. I'm going to distribute it here and distribute it here. So my 4n, nothing happens to it. I get a negative 30n squared and then minus 10. So that's from distributing that negative 5 right there through. Then this negative 1 needs to go through, so I'm going to get minus 3, and then I'm going to get plus 7n, because this negative times a negative became positive. Then I still have plus 20n squared. Okay, now I'm going to collect like terms. So I've got negative 30n squared plus 20n squared, so I'll write that down. Negative 30n squared plus 20n squared. Alright, let me see. I have 4n here and plus 7n. So I have 4n plus 7n. And then lastly, I've got negative 10 take away 3. So negative 10 take away 3. So now we combine these together. These are like terms, these are like terms, these are like terms. Putting those together, you should get negative 10n squared plus 11n and then minus 13. There you go. All right, and that concludes this first section.